Hello everyone. Today I'd like to talk about our work on image super resolution, the task of generating high resolution images from low resolution inputs. Recent advances have seen transformer based architectures become the state of the art in this domain, surpassing traditional convolutional approaches. However, transformers often come with quadratic complexity, higher data demands, and heavy computational requirements, which can lead to significant resource consumption. To address these issues, we developed a novel token mixing architecture called WaveMix. WaveMix employs the 2D discrete wavelet transform for token mixing. Unlike transformer models, it does not require converting images into sequence of patches. Instead, it processes the image in its 2D form, preserving inductive bias that improve data efficiency. Additionally, since the 2D discrete wavelet transform is a parameter-free operation, the overall model size is substantially reduced. The spatially lossless soundsampling property of HAR wavelets also helps lower GPU usage while boosting throughput. Previously, we demonstrated WaveMix's strong performance in segmentation, classification, and superresolution tasks. In this work, we introduced an enhanced and more efficient version called WaveMixSR-V2, which modifies the original WaveMixSR architecture in two key ways. First, we replace the transpose convolution operation layer with a pixel shuffle operation. Pixel shuffle is also a parameter-free operation and therefore greatly reduces the model size. To compensate for any potential drop in learning capacity, we add a conventional convolution layer right after the pixel shuffle step. In the initial design, if we wanted an 8x super resolution, we would apply a single 8x upsampling layer to produce the high resolution output, then use WaveMix blocks for refining the details. In WaveMix SR-V2, instead, we use multiple resolution doubling stages sequentially, which substantially cuts down the GPU consumption and increases the throughput. We evaluated WaveMix SR on the BSD100 dataset, which is a standard dataset for super resolution. Our findings shows that WaveMix SR-V2 outperforms the previous state-of-the-art models while having fewer than 1 million parameters, which is over 100 times smaller than comparable transformer-based solutions, also requiring less computation. Moreover, it is significantly faster to train and run inference compared to the first version of WaveMix SR. Here, we also show the qualitative results illustrating the effectiveness of WaveMix SR. Thank you.